the last 3 months, we've been designing a Hyperloop pod to compete in the SpaceX Hyperloop competition. But let's back up. Modern transportation has been evolving for the last 200 years, and it all started with the completion of the Transcontinental Railroad across America. Then came the highway system that connected every city across the country. And finally, the development of air travel. Today, even air travel is too slow. A new transportation system called the Hyperloop will cut travel time in half between large cities like Los Angeles and San Francisco. Hyperloop pods travel inside low-pressure tubes at speeds of up to 700 miles per hour. This past summer, Elon Musk of SpaceX announced a Hyperloop competition. University teams from across the country will design, build, and test pods in June of 2016. Now let's begin that update. When we sat down to design the pod, we wanted to make the pod as safe as possible, without compromising the aesthetic appeal of the pod. This meant sitting down with the 3D design team and drawing up sketches and then turning these sketches into 3D renderings. The design started out with 2 pontoons jutting out the side, and more recently, designs mimic the shape of a bullet or a torpedo. This new shape has been 3D printed and is currently being tested in the wind tunnel so we can verify our CFD results. With the shape selected, our next challenge was to choose and analyze a levitation system for the pod. The original focus was to float the pod on a cushion of air, but with the addition of an aluminum plate on the bottom of the tube, a startup company, ArxPax, released a new alternative, levitating engines. These levitating engines offer increased clearance height and more maneuverability inside the tube. A lot of people have asked what makes the Hyperloop different than maglev trains. Well, both are virtually frictionless and have a magnetic propulsion system, but what makes the Hyperloop different is the environment it is in. Hyperloop pods are inside a low-pressure tube, and therefore in a controlled environment not affected by the elements. They encounter significantly less drag than maglev trains. Another way the two differ is that Hyperloop pods are significantly faster than maglev, due to the way that they displace air when traveling inside a tube. The turbofan we have chosen will mount on the front of the pod and suck high-pressurized air into the pod, and release the air out the tail section of the pod into an area of low pressure. The other areas currently being analyzed include the braking system, control system, and frame construction. In the near future, a 1/10 scale model, approximately the length of a golf club, will be built to determine the optimal construction technique and material choice. We set a goal to raise $40,000 to build the pod. We have raised $8,000 of our $40,000 goal. In addition to Kickstarter, we have been busy contacting companies trying to attain sponsorship.